I'll just quickly kick things off. My name is Nicole Desiato. I'm the Customer Relations and Events Coordinator for Bedford Freeman West Publishing Group. We publish The Practice of Statistics, 5th edition, which is authored by Josh Tabor from Cannon Del Oro High School in Arizona. This is a webinar that's part of our full election professional development week. So we've been doing webinars every night this week, and we're doing 2 more tomorrow about the different ways that you can use the current events and what's on the news right now in your classroom. So Josh put together a presentation on using polls in a statistics classroom, so it's a good way to kind of keep your students interested in real-world events while also getting them some math practice. A few housekeeping things before we get started. You've all been muted to cut down on background noise. So if you do have a question, you can feel free to send it to me in the chat. You just need to select the host, and I'll get the message. We're also going to be taking questions at the end of the presentation. So if you do have any questions coming along, send those to me as well. I'll keep track of them, and then once Josh is done, we'll do a quick Q&A. That's pretty much it, so I will turn it over to Josh to get started.
Excellent. Thank you, Nicole. I had fun putting this webinar together. I've been kind of fascinated by some of the stuff that's going on these days in politics and reading lots of articles, and of course there's lots of references to things that we could use in the statistics classroom. So this is just a quick few ideas about how you might leverage some of the interest that kids have in the elections and the politics to enhance your statistics class. I do teach AP statistics, and I'm co-author on an AP statistics book. But the things that I'm going to be talking about today in the webinar would be fine also in a regular statistics class or an on-level statistics class, or even in an Algebra 2 class, say, that has some statistics standards that you might need to be addressing, or maybe colleagues at your school might need to be addressing. I will point out while we're on this opening slide that there's going to be some files that I'm going to show you and some articles that I'm going to reference, and I've put them all into a Dropbox essentially, but I made a tiny URL link to make it a little bit easier to remember or to write down and not mess up on a tiny little letter or symbol. And I'll repeat that link at the end of the webinar, and I think also Nicole might send that out when she sends out a follow-up email. So those files are all available by going to that link. All right, so 3 goals for the webinar. Number 1, to discuss how poll questions are asked and how bias can be introduced, and project ideas will be included. The second goal, to learn about the margin of error and how to estimate it using simulation, which, like I mentioned, is an Algebra 2 standard in many states. And 3, to discuss other issues related to elections, polling, etc., and again, articles included that are really, I think, very interesting and help to inform me as a statistics teacher and my students as well. All right, so on to the first goal. You can see the heading there, Response Bias and Donald Trump. So when I went around this semester, I do this every spring, trying to recruit students to take statistics next year. Lots of students don't have any idea what statistics really is about. They think it's just, making box plots or calculating mean and median and mode. But really, we know it's a lot more than that. And so I started my recruitment presentation by asking a question: who's ever heard of Donald Trump? And right away, there was lots and lots of interest among the students. Some people were, disgusted. Other people were interested or happy. But there was a lot of interest. And so this is what I did with them. I showed them a question that was asked by NBC News in the Wall Street Journal. This question was asked, I think in December, which was shortly after the attacks in Paris, where there was unfortunately, hundreds of people killed. And Donald Trump had some pretty noteworthy statements about what he would do if he was president in a situation like that. So here's the NBC News question. It said, recently, Donald Trump has called for a total and complete shutdown for any Muslim being allowed to enter the United States. Do you favor or oppose this proposal? or do you not have an opinion one way or the other? When they asked U.S. Residents this question, 25% said they favor such a shutdown, 57% said they opposed, so that's a negative 32, meaning 32 percentage points less people favored this proposal than opposed it. Okay, so quite a bad turnout if you're Donald Trump. This came from a New York Times article that was posted on the AP teachers community, which I'll be honest, I get a lot of my ideas from other teachers. I think we all do, and that's one of the great things about watching webinars, going to workshops, paying attention to the AP community, is you can get a lot of great information. I don't read the New York Times every day, but I'm glad that people do, and they post articles when they come up. Now, here's another question. This was done by a different polling organization, the Rasmussen Reports poll, asked at the same time and about the same issue. It says, do you favor or oppose a temporary ban on all Muslims entering the United States until the federal government improves its ability to screen out potential terrorists from coming here? Now, when the question was asked this way, 46% favored the proposal and only 40% opposed. So a positive 6%. Okay. So thinking about the previous question, it was negative 32, and in this case, it was positive 6, a difference of 38 percentage points. When really the question was essentially asking the same thing, asking about Donald Trump's proposal that he made back in December. So now let's look at the questions back to back. So this is the first one, and I bolded a few key words. It says, Donald Trump has called for a total and complete shutdown. The second question says, do you favor or oppose a temporary ban on all Muslims entering the United States until the federal government improves its ability to screen out potential terrorists from coming here? You can see that even though they're asking basically about the same issue, the first question emphasizes the total and complete shutdown, which makes it seem permanent and universal. Whereas the second one says temporary, which is obviously different than total and complete, and it gives a criteria for when this ban might be lifted. And so now that you look at the wording back to back, it seems not surprising that you'd get a difference in response. A 38 percentage point difference is still quite big, but you can tell that the wording of the question makes a big difference. And so I gave those two wordings to the students I was recruiting, and then talked about some projects that we do in class that really gets at this idea of the wording of the question. Okay. Before we move on, I wanted to show you one other example. This was done by the Quinnipiac University. I hope I pronounced that right. They did a test about language, and they did this on purpose, where they asked questions. This is a regular, they do lots of polls. Half the respondents were asked one question, and the other half the respondents were asked a question with a different wording. And it was random who got which wording. So in theory, the two groups of people that they asked were essentially identical as far as political beliefs, certainly beliefs about gun control and other things like that. So any difference that you got in response was likely due to the wording. In one question, they asked about support for stricter gun control laws. In that group, they got negative 46 to 51, so negative 5 essentially. 5% fewer people had supported than opposed. But when they asked for just stricter gun laws without the word control, they got a positive difference of 7%. So from going from negative 5 to positive 7, just by subtracting the word control. Now that's not as big of a difference in percentages as the Trump question, but it's also not that big of a difference in the question wording. Only one word, but you can see that it makes a big difference. And in fact, in this case, if you were writing a headline based on the first one, you'd say that majority oppose stricter gun control laws. Whereas if you were writing a headline for the second one, you'd say majority support stricter gun laws. And that could lead to very different headlines and very different groups of people being happy about the outcomes. So again, one word can make a really big difference. And having kids think about this and getting them to look at the original wording of the question rather than not just paying attention to the headline or the way somebody's trying to spin the results is something that I hope my students take from my class and remember for the rest of their lives. I'm sure they won't remember the conditions for a two-sample t-test, but if they can remember some of these questions about these issues about response bias, I'll be really happy. Okay. There's the source for this Quinnipiac University study. Both of these articles are in the Dropbox folder that I linked at the beginning. So you can see those or you can go to the actual websites. So now I want to talk a little bit about a response bias project that I do with my students every year in the fall semester, so first semester. In this coming year, I think I'm going to do a special election edition. Typically, I let them choose whatever topic they want, but to leverage, again, interest in the elections and to point out, all the difficulties that we can have doing political polls, I'm considering doing this as an election edition. Okay, so it says, this is the heading of the assignment I'll give my students. It says, you and your partner will design and conduct an experiment to investigate the effects of response bias in political polls. You may choose the topic for your surveys, but you must design your experiment so that it can address at least one of the following questions. Can the wording of a question create response bias? And we've seen two examples of that, right? With the Donald Trump questions, you got very different results based on the wording of the question. Same thing with the gun control questions. Does providing additional information create response bias? Sometimes political polls might lead off with a question, did you know that such and such candidate voted to support this or voted to oppose that? Or, you can fill in the blanks with any kind of positive or negative information and then ask a regular question and see if that additional information creates response bias or gets people to say yes or say no more often than just a plainly worded question. How about the characteristics of the interviewer? Do those create response bias? Maybe if somebody's doing a poll to see if people like Hillary Clinton, for example, would it make a difference if the interviewer was female or the interviewer were male? Or if it's an in-person interview, man on the street kind of doing interviews, what that person is wearing. Are they wearing a, Feel the Burn shirt, supporting Bernie Sanders or, different things like that? How might that affect people's responses to questions? Does anonymity change the responses to sensitive questions? This is a really interesting topic right now, especially with Donald Trump. There's some discussion about whether he does better in primary types, just election type primaries versus caucuses, where people have to be a lot more public about who they're supporting. And there's some, theories that people might not be as willing to be open about supporting Donald Trump, and so that's why he's done worse in some of the caucus states than some of the other states. Of course, there's plenty of other explanations, but you can imagine certain questions about politics or certain questions about other topics where people might not give an honest answer if they have to give it to you face to face. Does manipulating the answer choices or the order of answer choices change the response? There's an article in the folder that talks about how a polling organization, asked about, do you approve of this person? Do you approve of this person? Do you approve of this person? And the responses that they got vary depending on the order. For instance, if you're asking about somebody terrible and then you ask about somebody neutral, the neutral person might actually get a lot more positive reviews just in contrast to who was asked before them. So there's a way to introduce bias that way. And can revealing other people's answers to a question create response bias? So if you knew that your neighbors had already answered a certain way, or you could see the interviewer's clipboard, would that influence you to go with the majority? Is that kind of a peer pressure thing? Does that create response bias? So my students have done examples of these. I'm going to break away from the PowerPoint just for a second to show you a couple files. So in the Dropbox, these are the files you'll see. This one, Response Bias Project, Election Edition, you've already seen the first paragraph, essentially. That's here, this project. Then it goes on to describe the proposal, what kids need to do in their proposal. Really important that you have your students do a proposal. One, so that you can avoid any scandalous topics that you wouldn't want your administrators seeing and if they came in during presentation day. But also just to make sure that your students are understanding the purpose of the assignment and they can do things well. Then I have my students do a poster that I can hang on my wall. I like to show off student work and they like to look at each other's work. So there's some details about the poster. Then on the next page, I have a rubric that I use for grading the project. So that's all there for you. You can, it's in Word format, so you can, cut and paste and make any adjustments that you want, but you're free to use that. The other thing I wanted to show you, I've got some student project examples. One nice thing about posters is you can take pictures of them that are easy to display. So this question, how honest are people about what they eat? So these aren't political questions necessarily, but this group asked people how many times they eat fast food per week. But half the people had to answer in person, face-to-face with the interviewer. The other half the people got to fill out a secret ballot where they circled a number and then folded it up and put it in a box. And they found that when people were able to answer anonymously with the secret ballot, they admitted to eating fast food more often than the people who had to answer in person. Now, I'm showing you these projects. None of them are perfect, so don't judge me by these posters necessarily. I just thought they were good examples. This one is how do hunger statistics influence responses on charity? So these students basically asked a question about whether people plan to donate to charities during the holiday season. And half the time they were given additional information about the number of people in Tucson where we live that are below the poverty level and that the percentage of children that go hungry on occasion. And so with that extra information, did that change people's responses about charity? Okay. This next one, would you buy the ticket? Again, not super elegant as far as the poster, but they had a pretty cool question about influencing whether the wording influenced the response. They basically said, would you buy a $10 lottery ticket if you had a 30% chance of winning? The other half the people got a question, would you buy a $10 lottery ticket if you had a 70% chance of losing? Well, of course, that's the same statement, right? A 30% chance of winning and a 70% chance of losing. But a lot more people would be willing to buy the ticket with the 30% chance of winning rather than the 70% chance of losing. Again, showing how the wording of a question can have an influence on how people respond. This one, do you like tattoos? This is about the characteristics of the interviewer. They asked people in the mall if they like tattoos, but half the time the two girls who were doing this were showing their tattoos. The other half the time they were wearing a jacket so their tattoos were covered up. They were thinking that if people could see that they had tattoos, that might change the response. And again, you could easily change this to a political thing, maybe wearing a recycling t-shirt or some t-shirt that showed some sort of political party affiliation or support for some candidate to see if that would make a difference. And this one, do you even lift, bro? Was a guy who stood outside a Planet Fitness workout place and asked how many times per week do you work out as people came in. But one time he had a clipboard, you can see that kind of on the left, where he had a bunch of tally marks already registered for 2 and 3. And then the other half the people he asked, he had a clipboard where most of the tally marks he'd already pre-filled in at 6 and 7. And when he asked the question, he made sure that the person who was answering it could see the clipboard so they could see what everybody else was saying to see if that influenced their response. And on average, it made about a half a day difference. The people who saw the chart on the right that had lots of 6s and 7s tended to give higher answers than the people who saw the chart on the left. Again, that's showing other people's answers. So those are just some examples of student projects that my students have done that address some of these issues about the wording of a question, about additional information or characteristics of the interviewer, anonymity, and revealing other people's answers. This is a project I've done every year. I think it's very memorable to students, and what it does is it creates an awareness in their minds about the problems that can arise in surveys. And it makes them, I hope, much better critical thinkers when they read newspapers and they read media reports because they know to ask themselves these questions. All right. Second topic, margin of error. So obviously this is a topic that you could spend almost an entire chapter talking about. So the perspective I'm going to try and introduce here is what you might do at the beginning of the school year or towards the beginning of the school year if you're thinking about the election coming up in November. If you're teaching a statistics class and you're already in second semester, you have a lot more tools in your toolbox that you can use to talk about margin of error. So the perspective I'm giving you here is what you might be able to do, say in October, maybe after you've done a little bit with normal distributions, after you've done a little bit about study design, you can do the kind of things that I'm going to be showing here. So this is a Monmouth University poll that came out on Monday. It said Donald Trump is leading Marco Rubio in the Florida senator's home state by 8 percentage points. A Monmouth University poll out Monday, that was just this past Monday, shows, says Trump has the support of 38% of Florida's likely GOP voters compared to 30% who back Rubio, 17% for Texas Senator Ted Cruz, and 10% for Ohio Governor John Kasich. Monmouth survey 403 Florida voters likely to participate in the GOP primary from March 3 through 6. Now we're going to come back to a couple of those issues. Says likely to participate. How exactly that's determined is a really controversial topic and one that polling organizations really struggle with, and it's kind of a moving target. So again, we'll talk more about that later, but let's assume for now that they were able to obtain 403 genuine Florida voters who are likely to participate in the primary. It says the poll's margin of error is plus or minus 4.9 percentage points. So students, if they've paid attention at all to any kind of media reports about any kind of surveys, whether they be political or not political, have probably encountered that language, plus or minus 4.9 percentage points, or plus or minus 3 percentage points, or something like that. It's called the margin of error. There's the reference to this article, and again, the article is in the Dropbox as well. So informally, again, this is something that I would use, this language I would use with my students first semester, before we know anything about confidence levels and critical values and things like that. It would be informally, the margin of error measures the maximum distance we expect the truth to be from our estimate. And so it's not the absolute maximum distance, it's just the maximum distance we expect. Second semester we'll put a number on that. We'll say that we're 95% confident that the interval we have or the margin of error we have would extend out to the outer limits of what we'd expect. But for right now, just using the we expect as sort of a more general term to talk about that margin of error, the maximum distance we expect the truth to be from our estimate. So what this means, in this poll, our estimate for the percentage of people who support Donald Trump is 38%. The margin of error for this estimate is plus or minus 4.9 percentage points. This means it's plausible, and I like using the word plausible. It's a synonym for believable, and it's a little bit more restrictive than the word possible. Really, anything is possible. And so I want my students to distinguish what's possible from what is plausible or believable. Another way to say that is what's not surprising. So it means it's plausible that the percentage of likely GOP primary voters who support Donald Trump could be as small as 33.1% or as large as 42.9%. That's quite a range, but remember they only surveyed about 403 likely voters, and that's why we get a fairly big range for those percentages. So again, if it turned out that 34% of GOP voters preferred Trump, that wouldn't be surprising. If it turned out to be 41%, that wouldn't be surprising, according to this poll. If it turned out to be 50%, that would be surprising. That's outside of our estimate plus margin of error. And so that would be, certainly possible, but it wouldn't be plausible or believable, at least based on the survey that was done last week. Now, this is just a side note. Understanding the margin of error in this way is tested on the new SAT. That's one of the ways I keep myself busy is I work with the College Board on reviewing and evaluating SAT items, in particular statistics items. And I think it's really good news for us as statistics teachers and as just citizens that students on the SAT are being assessed on their understanding of margin of error and what it means. They're not going to be asked to calculate it in any way, but they are going to need to know that what the margin of error tells you is sort of what defines the range of plausible values for what the truth could be. And it could be about a proportion, it could be about a mean. So something good, especially if you've got seniors in the fall. They're often taking the SAT. So spending some time talking about margin of error, even though it's officially a second semester topic in most AP classes and regular classes, would be a really nice thing to do to get them a little bit of an advantage on the SAT if they happen to take it in, say, October or November. All right. So now, estimating the margin of error. How are we going to make that happen? Well, second semester, there's a formula for it, right? It looks like this. Margin of error, z star times square root p hat, 1 minus p hat over n. And I suppose that you could give that to students first semester if you want, but I think they'd think of it as kind of just a mystery what that's all about, because we haven't learned anything about random variables. Maybe you've learned a little bit about normal distributions, but it would be kind of just forcing it on them. So what I think is a better way, and what a lot of states, including the Common Core, encourage students to do and teachers to do, is to do a simulation to estimate the margin of error. So I'm going to give you an example of how we might do that, and then we can talk later on in the question and answers about maybe other approaches that you might want to use during first semester before you get into the official formula. Okay. So to estimate the margin of error, we need to know how much the sample proportions typically vary from the truth. That's something that we do sometimes first semester just as an activity, just to introduce the idea of sampling variability, that when you take a random sample, even though in theory it should be representative of a population, the estimates you get from that random sample will likely vary a little bit from the truth. Sometimes those estimates might be a little too small, sometimes they might be a little too large, just depends on the chance of who was in the sample. Okay? So kids, I think, pick that up pretty well. But thinking about how much they typically vary from the truth is a little bit more challenging. So for this little activity, we're going to assume that 38% of all likely GOP primary voters in Florida support Donald Trump. Okay? Now, that's just our estimate from the sample, but to get a sense of how far the sample proportion might vary from the true proportion, to do a simulation, we have to kind of assume the truth, and then we'll see what could happen in random samples. So we're going to simulate taking a random sample of 403 voters and seeing how the sample proportion varies from the true proportion. There's ways we could do this. One way would be a spinner. It'd be a little hard in this context because of the sample size, but you could set up a spinner with a 38% region that says Trump, and then a 62% region that says not Trump, and then you could spin it 403 times. Each spin would represent one voter in the sample. And so you spin it 403 times, keeping track of how many times it landed in the Trump zone, and that would be your estimate for the proportion who would support Trump. We'd expect it to be around 38%, but it might be 37%, it might be 40%. The goal of the simulation is to figure out how far away from that 38% it could actually be. You could use random numbers, of course. 1 to 38 represent Trump, and 39 to 100 represent not, and then generate 403 numbers from 1 to 100. Or you can use an applet. Applets is my preference because it's faster, and it could deal with, we can do many trials very, very quickly. So I'm going to show you an applet. Oh, I wish it didn't show you the front screen, but I'm going to show you an applet and there's the link. I'll give you a second if you'd like to go and kind of follow along in a side browser. These are some applets we're developing for a book that Darren and I have written called Statistics and Probability with Applications. It's intended to be an on-level statistics book for kids that have finished Algebra 2, maybe looking for a fourth year of math that's not pre-calculus. It doesn't cover all the topics that you'd find in an AP course, and it's written at a level specifically aimed for that 12th grade student who's just coming out of Algebra 2. Another noteworthy thing about the book is it's written up in lesson format, so each day is kind of a separate lesson, like you'd see in a more traditional math class. So it'll make both students and math teachers, I think, feel very comfortable, especially if they're new to statistics. And so one of the things that we've done to try and help out students and teachers that are teaching this course is create a set of applets that can be used as calculator replacements for students who don't have graphing calculators or schools who can't provide graphing calculators. So these applets will do everything that a graphing calculator will do, plus much more. And they can be used on any mobile device or anything like that. So feel free to play along. I'm going to escape out of the PowerPoint and kind of do this live. Okay. All right, so here we go. This is what you get when you go to that link that I sent you. We're going to click on one categorical variable. This is categorical data. And this is, we'll say, just preference for the variable name. There's one group. There was one sample of people in Florida. And then there's Trump as a preference. That was 153. And then not Trump was 250. And I figured that out. 38% of 403 is roughly 153. So that's just entering our data. And I press the Begin Analysis button. What it does is it shows you a bar graph, okay, of frequency. You can change it to relative frequency if you want. It just changes the scale. You can look at the summary statistics. Again, 38% Trump, 62% not Trump. Okay? And then at the bottom, you've got perform inference. So it includes all the regular traditional techniques, a one sample z-interval, a one sample z-test, a chi-square goodness of fit test. But what we're going to do here is we're going to go down to the fourth option, which is simulate sample proportion. Again, I'm imagining that this is happening first semester when students don't know what a z-interval or a goodness of fit test is all about. So simulate sample proportion. It says category to indicated success is Trump. That is, we're trying to figure out what proportions support Trump. And it says we want to simulate the distribution of the sample proportion for samples of the original size, assuming that the true proportion is equal to, I'm going to put the observed proportion. Remember we had said, let's just assume it's equal to 0.38. Okay? And then add this many samples. So I'm just going to start with one. Okay? Now you hit perform simulation, and you can see in that particular sample, I got a sample proportion of around, looks like 0.34 or something like that. Okay. Now I can keep adding. I'm going to go 10 at a time. If I click 10 and perform simulation, what that does is it takes a sample, 10 different samples of size 403, each time calculating the proportion who support Donald Trump. Okay. Notice that 38% is what we'd expect. Some of the time we're more, some of the time we're less. If I keep pressing perform simulation, it keeps taking 10 samples of size 403 and piling these dots up. Okay. You can follow along down. I'm at 191, so let me do 9. That gets me up to 200, and then let me do 800 more. That takes me up to 1,000. So I've done 1,000 samples of size 403. Notice that on average, our sample proportion is 0.38. That's not surprising because that's what we said it should be. But what I care about is the standard deviation. Now, first semester, kids should know what standard deviation is. This is typically, or on average, how far our estimate, our p-hat value, is varying from the truth. So the question we asked on the PowerPoint earlier, how much do these sample proportions vary in samples of size 403? Well, typically, according to this, they vary by about 0.024. And that's typical. So that means on average about 0.024, sometimes more, sometimes less. And of course, you can crank this up if you want. The applet is really good at that. I can do 10,000, press perform simulation, and in less than a second, it does it again. So I'm at 0.024 still. I can add another 10,000, and it does it again. I'm up to 21,000 samples, and I've got a standard deviation of about 0.024. All right, so I'm going to jump back to the PowerPoint now. Just in case the applet wasn't working, I have screenshots here, so we'll zoom through those. And that's just a screenshot of the display. And this is a screenshot of the screen that I just showed you. Slightly different numbers because, you know, it's a different time, different simulation. So the standard deviation here was 0.025. And so on the right-hand side, you can see that the estimated margin of error is 2 times the standard deviation, where the standard deviation is the standard deviation of the sampling distribution of the sample proportion. How far the sample proportion tends to vary from the truth on average. So now why do we use 2? Okay. Well, in my class, students have already had some exposure to normal distributions. And they'll know that if you go out 2 standard deviations in each direction, then that should include about 95% of the values. And so I'll just tell my students that that's typical with what statisticians do when they're calculating margin of error. They want to have 95% confidence. They want to know that if they do this process over and over and over again, 95% of the time the values will be within the margin of error. And I think everything that I just said, even though that's an interpretation of confidence level, is accessible to kids first semester, especially if they've seen stuff with normal distributions. So in this case, using the simulation, we got a margin of error of 2 times 0.025, which is 0.05. Now remember, in the article, it quoted a margin of error of 4.9 percentage points. So our simulated value is very, very similar to the reported margin of error. So again, this is something that you can do first semester, and I think it's fairly accessible to students, and might be a really interesting, motivating thing to do as elections are getting closer and closer. All right. Last thing, and this won't take too long, other interesting issues. Mostly what this couple of slides is going to be about is recommending that you spend a lot of time at this website, 538.com. It's a great source for data-based analysis of politics, sports, culture. The editor-in-chief is Nate Silver, who was famous in my world years and years ago because I'm a big baseball fan, and he used to kind of do exclusively work with analytics in baseball. Then for whatever reason, he moved over to politics, and that's where he became famous to most people as one of the few people that correctly predicted the outcome in every state in the last presidential election. So that was his claim to fame, and he's got now a lot of great people working for him that write a lot of interesting articles at 538.com. So one of my regular places to go. One question that's a really important question that I mentioned earlier is, who is a likely voter? So you'll hear that a lot. Among likely voters, this many percent would support this. Well, how do they determine likely voters? It's a moving target. It says constant adjustments are being made every election cycle. Some years the choices favor Democrats, other years Republicans. And so you'll hear it. I think, let's see, we're talking in the 2012 presidential election, it seemed like the polls were favoring Democrats, or maybe I've got it reversed. And by favoring, I mean that on average, the polls overestimated support for Democrats by a couple percent. So what companies do, polling organizations do, is they go back and say, oh, wow, we were consistently overestimating support for Democrats. So let's tweak our formula for how we decide who a likely voter is. And of course, what happens? The next time around, they tweaked it too much, and now their polls tend to over-support or suggest give extra support for the Republicans. So the Democrats complain, Republicans are happy, but then the pollsters go back and figure it out. And so every year, one of the two parties is complaining, but if they just look back in history, it's been pretty much on average about the same. It's just a constant cycle of readjustments. So there's 3 articles that are in the folder that are really good. And I'm not going to summarize them for you any more than I already have because it would take a lot longer. The first one is why polls tend to undercount Democrats. That was written before the 2014 election in the New York Times. And then after the 2014 election, this article, the polls might be skewed against Democrats or Republicans, was kind of a response by Nate Silver in 538. And then an article that was just posted yesterday, how the polls missed Bernie Sanders' Michigan upset. So most polling organizations in the Michigan primary, which was just on Tuesday, had Hillary Clinton ahead by somewhere around 20 percentage points. And it turned out that Bernie Sanders actually won the primary for the Democrats, which was a huge upset as far as, compared to what the polls were saying. So the article goes and talks a little bit about different reasons why that might have happened. And one big reason is not correctly assessing who a likely voter was. And in this case, it had a lot to do with age. They, based on previous data, anticipated that not that many young people were likely to vote. And the youth turnout was much higher than expected. And the youth tended to favor Bernie Sanders, and that obviously made a big difference in the election. There's some other interesting explanations about maybe some Hillary Clinton supporters thought that she had it in the bag, so they voted in the Republican primary. In Michigan, it's an open primary state, so you can vote in any election you want. You just get one choice. So there's other interesting theories, too, in that article. So please read that. Again, all those are in the folder in the Dropbox. How do we reach likely voters? So once you've decided who a likely voter is, how do you get a hold of them? There's a huge problem with non-response. Most of these political polls only actually talk to about 10% of the people that they call, which is very troubling. It still seems to work. They figure out some ways to make some adjustments afterwards. How about cell phones? Do you call cell phones? Some people are cell phone only. Other people have landlines. Some people have both. Lots of people have both. How does that handle? How is that handled? Robocalls. Those are automated surveys. If you support Donald Trump, press 1. If you support Marco Rubio, press 2. They're not live people. And so there's a concern that maybe responses to those are not as reliable. Okay. So there's a couple interesting articles. This main one, is the polling industry in stasis or in crisis? It's a really good summary of a lot of these issues written by Nate Silver. Again, that's in the folder. So that's it. I wasn't expecting to talk for 45 minutes, but there I am. I hope that this was able to give you just some ideas of things that you might be able to incorporate. Maybe it's this year, but certainly at the beginning of the school year next year, that might take advantage of kids' interest in politics and interest in these elections to be a little bit more motivated in your classroom. And again, there's the files are available at that website that's written right there on the right. And I'd be happy to take any questions that people might have.
We actually did get one question already, so this question comes from Sharon. When in the year do you typically do the response bias project?
Great question. I typically assign that about halfway through the first semester, mostly because I want students to have experienced a little bit of the rigor that I expect. So I want them to have taken a few tests and have received those tests back to understand the sort of level of expectations I have, which usually means it's due around Thanksgiving time. This coming school year, I think I'm going to push it up a little bit earlier, though, so they can get it done before the election in the beginning of November, because I want them to be able to ask questions while the election's still on everybody's mind, and while those questions are still valid, like who do you think you're going to vote for? They're going to ask that after the election and be a little troublesome. So I would say, and we start in August, so maybe assign it at the latest end of September.
Thank you. Our next question comes from Jessica. Do you think the semester one project that you discussed would tie in nicely to a 2-proportion z-test possibly good review for the AP test if there's time?
Absolutely. In fact, the one that I showed you about tattoos I led off with that project as my way to introduce a two-sample z-test for a difference in proportions. We started doing a simulation, but then we talked about the analysis. And yeah, it's great. Not all the time, not all the projects, the conditions are met exactly for inference, but that is a great follow-up to have students go back to their project, think about how they would analyze it now that we know more formal inference techniques, and then see whether the differences they found were statistically significant.
All right, the next question comes from Paul Myers. There are 10 candidate signs in my neighborhood, of which 8 are for Trump. So should we assume that 80% of the voters are for Trump?
That's a great question. I don't know. I would assume at least 8 are, unless those are like vandals posting signs in other people's yards. But that's a great question to ask. Whether sort of these public pronouncements by some people are really valid. It kind of goes back to the anonymity issue. People who are willing to put the signs out in front obviously aren't afraid to reveal their feelings, but lots of people who don't have their signs out might be, and you really have no idea what they're saying. You can talk about it in terms of non-response also, that you know, if only 10% of people are responding to your survey and 8 of those 10 like Donald Trump, the other 90 who didn't respond, who knows what they would say. Okay, so it's a great question to ask students and see what they say.
Great. Does anyone else have any more questions? You can send them to me in the chat. While you're thinking, I will say that we are going to send out this recording, so you can feel free to share it with your colleagues. And I will also include the recording and the URL that Josh mentioned. Great. We got another question from Jessica. What's a quick way to get a representative sample for data within the school?
That's a good question. And that's something that my students struggle with. So with regard to like the response bias project, kind of 2 comments. One is that really it's a project that's about surveys, but it really is an experiment where the key thing is random assignment. And so I try to emphasize with my students that you may or may not be getting a representative sample of the school, but as long as you randomly assign the treatments, like which people get which version of the question, then at least you can make a cause and effect conclusion about people like the ones that you got in your sample. If you really want to try and get a representative sample at your school, I guess there's a couple of ways. I mean, one, it would be really tedious, and that's actually getting a list of all the students and, you know, putting all their names in a hat and mixing them up and then trying to track them down. That would obviously be very, very, very time consuming. What my students do, we have 2 main entrances to our school, and so they'll wait around from, you know, early in the morning and then, you know, ask every 10th person that walks in to participate in the study. And, you know, they've covered both entrances, and so pretty much everybody has an equal chance to be chosen. Obviously, there's kids that are absent and, you know, kids that come in, you know, odd entrances and things like that. So what I expect them to do in their project report is talk about any limitations that they have. So the kids who do their study at the mall, they'll say, well, this really only applies to people who shop at this mall on Saturdays. And I'm happy with that. And I'm also happy that they realize, wow, it's hard to get a true random sample. Lots of kids talk about that in their presentations, that they really had a hard time getting people to participate and a hard time really believing that their sample was representative. So in this case, as long as they're honest about their limitations, I'm happy with what they do. Good question.
Our next question is from Amy. She says, I'm interested in the on-level stats book that Josh mentioned. What is the title and when will it be out?
So it's called Statistics and Probability with Applications. We're wrapping things up we're in the middle of the production process. So basically what that means is it should be ready in electronic form at the end of the summer. And there are schools who are going to be using it next year. The actual print book is scheduled to be off the printing press right at the beginning of October. But it'll be available electronically, about 6 to 8 weeks ahead of that. And if you want to just email me, I could give you some more information about that, including like table of contents, some basic information about how it's going to be structured. And then we're hoping in about a month or two to have a website up that will show an actual sample chapter. But we're not quite to that stage yet, as far as making sure everything's, all the typos are gone and stuff like that.
Yeah, and I can say that we are working on getting some sample materials up. We have our marketing assistant who creates our wonderful websites on this call as well, and I'm sure she's upping her timeline for this because we've had a lot of interest in it. So as soon as we get that all set up, we will be sending out emails about it. If anyone's going to be at NCTM in San Francisco at the end of April, Josh and Darren are doing 2 workshops on one's on AP statistics and one's on the general level statistics book. So if you're going to be at NCTM, definitely check those out because we will have some materials for you there. But if you do have questions, you can feel free to either email Josh or myself, and we can, I'll send you guys all my email address, and I can put you on a list to make sure that you get information as soon as we have it. Our next question is from Jessica. When is the next webinar and what topic is it? Thanks, this was a really great one. So we plan these kind of as they come, but we hopefully will be able to do another, either probably in the fall. And you can find information about that. We'll be emailing it out about a week before. Does anyone else have any other questions? Josh, do you have anything left or anything?
I think that's it. I appreciate all of you sticking around and listening. And if you're listening to this, online somewhere after the fact, thank you for sticking with us and listening all the way through the end. And I hope that these ideas are helpful to you, that they can enhance your class.
Yes, and thank you guys all for joining tonight. I'm going to be sending an email to everyone that registered with the link and the recording. Please feel free to share it with your colleagues and definitely take a look on our YouTube channel if you'd like to see and hear more about some teaching strategies from Josh. He's done, oh my God, how many webinars now throughout the years?
Definitely several.
Yes.
For sure, about AP exam review, AP exam tips, a couple other things.
And I can send you guys all the links to that as well in my email. So that you can expect my email to come early next week. We're going to edit the video a little bit, and then I'll send everything out at once. But yeah, please take a look, and thank you so much for joining us tonight. And thank you for all the thank yous coming through on the chat. I really appreciate it.
Yes, thank you for the nice words.